Okay, so this is Math 200, Review 3. We're looking at page 2. So multiply. So we're going to do FOIL, or the distributive property, twice. That is x times 2x, x times 9. And then we're also going to take negative 4 times 2x and negative 4 times 9. So let's see, x times 2x, 2x squared. X times 9, 9x. Negative 4 times 2x, negative 8x. And negative 4 times 9, negative 36. Then we combine like terms. So we have 2x squared plus x, or 1x if you'd like, minus 36. And that's our answer. So this is a second degree trinomial. It's a second degree because there's only a single variable in this term, and that's the highest power thing. So you do not take the 2 plus the 1 and say third degree. That's only if they're different variables in the same term. So this is a second degree trinomial. All right, number 8. Very similar. We're going to write it out twice. 4x plus 9 times 4x plus 9. Do yourself a favor, write it out like that twice. And now just do the distributive property twice again. We've got that and that. So let's see, 16x squared plus 36x plus 36x plus 81. And then we can combine those middle terms together, 72x plus 81. Again, if you did enough of those on the homework, you might have remembered that you can take the 9 times 4 is 36, and then double it, and then, square that thing and square that thing, and that'll be the bookends. I think it's just as easy just to multiply it out, though. All right, let's take a look at this. Ooh, this is a conjugate. Let's see what happens with conjugates. So I've had students say, well, conjugates, that's just opposites. It isn't. An opposite would be negative x minus 3y. Only one of the signs get changed, so it's called a conjugate. So we have x squared minus 3xy plus 3xy minus 9y squared. Now, if you wanted to write it 3yx, and that would be fine, then write negative 3yx and plus 3yx. But pick one of them and go with it. Don't make it xy and then yx, because you might forget that they're like terms, and we can combine those. So these are like terms, and they do combine, and they cancel each other off. So we end up with just x squared minus 9y squared. Excellent. And then the last one is a binomial, a first degree binomial, times a second degree trinomial. So we're just going to do the distributive property twice. Again, this times this times this. So we got 5x to the third minus 7x squared plus 2x. And then we're going to do this times this times this. And I saw in the book an interesting technique where they kind of line it up. So look, if I take 4 times 5x squared, that's 20x squared, and negative 28x and 8. And so see what I mean? How you can kind of line up this second row so it matches up with the first row. And now we just kind of add straight down. So here, we'll put the plus over here. So we got 5x to the third plus, what is that? 13x squared minus 26x plus 8. And there we go. So let's do the next problems. Oh boy, it's long divide. I know none of us really like too much to long divide. So let's add another color here. So long division works just like long division worked when you were just using numbers in arithmetic. We're just using variables now. All right, so you ask yourself, what do I multiply 4x by? So it exactly matches 36x to the third. You always just focus on the first number there and the first number here. So this is a third degree polynomial with 4 terms. First degree binomial with just 2 terms. So 4x times what gives me 36x to the third? That should be what? 9 times 4 is the 36, and then x squared times x is x to the third. So we write that down. And now we go back up to the problems that I already erased and do the distributive property. So we have 36x to the third minus 27x squared. There's one thing here, and this is a very important thing. Whenever you're long dividing, you subtract off what you take this times that, and then write it down here, and then subtract it off. It's a little more complicated when you're subtracting a binomial, because you have to change this sign and this sign. You're subtracting the entire binomial. So the negative hits both of them. It hits this, and then that changes from a minus to a plus. I usually make my pluses like super long, so I know I changed it. So now, first term should always cancel away. If that didn't cancel away, you did something wrong. Negative 11 plus 27 is positive 16. Oops, wait, I wanted that to be in black though. Positive 16x squared, and bring down the next one, minus 8x. And now we start again. It's 4x times what gives me 16x squared. So plus 4 times 4 is 16. X times x is x squared. So 4x should do the trick. Do the distributive property, 16x squared minus 12x. And again, we're going to change both signs. So this positive becomes a negative, and this negative becomes a positive. I add straight down. Those get canceled away, and this ends up 4x. We bring down the minus 3. And now 4x times what gives you 4x? That should be a big old 1. And so 1 times 4x minus 3 is 4x minus 3. And that should zero out, right? Because we have a minus here, a plus there, so that's going to be 0. And so that is our quotient. Because this remainder is 0, it went evenly. So if I wanted to double check, I could take this answer, multiply it by this, and I would get that. All right? So that was 11. We could do 12. We'll sneak in 12 here. That's just factoring out using greatest common factor. So 14 a squared b squared minus 21 ab squared plus 7 ab. Okay, so we look at 7, 21, and 14. What's the biggest number we can pull out of every one of those numbers? And the answer is 7. So we're looking for the greatest common factor. That is 7, and then as far as the variables go, we have a squared, we have a, we have a. So it's always going to be the lowest power thing, a. We have b squared, and just b, so it's b. So 7ab is my common factor. I write that down, I do a big old empty set of parentheses, and then to figure out what goes inside of those parentheses, whatever I wrote down here, I write it underneath each term. and then I reduce it term by term. So 7 into 14 twice, a squared on top, a on the bottom, so 1a left, b squared, b left, minus 7 into 21 3 times, a's cancel out, b goes into b squared, 1b left up there, so 3b. And b's cancel, a's cancel, 7 divided by 7 is 1. Don't forget the 1. A lot of people mess that up. They think 0. You're thinking add, subtract. Don't think that way. We're dividing. 7 divided by 7 is 1. And so that's it. It's factored completely. We factored out 7ab. Let's do, oopsie, gravity. Oh no! Gravity intervened there. So let's take a look at the other two problems on this page. I think we're going a little over 10 minutes. So 14 is x cubed plus 27, and 15 is 6x squared minus 54. Okay, so first, this is a perfect cube plus a perfect cube. So when we think of that, rewrite it into perfect cube form. So x to the third, that was easy to rewrite, but 3 to the third is 27. 3 times 3 is 9 times 3 is 27. So you always want to write it like that. Then you really have to only memorize it's a binomial times a trinomial. So a binomial times a trinomial. If this is a plus, we put a plus there. If that was a minus, we go minus plus plus. If it's a plus, we go plus minus plus. So like a plus sandwich with minus innards. Like the bread is the pluses and the minuses, the stuff inside. Now you just do this all. It's factoring, but it's kind of a very memorized format of factoring. Whatever you have here goes there. Whatever you have there goes there. So just that goes right there. That goes right there. This first term on the trinomial is whatever this is times itself. So x times x, that's x squared. The last term is always whatever this thing is times itself. So 3 times 3 is 9. And then the middle thing is just those two multiplied, 3x. And we're done. It's factored. So it's sort of a memorized process. The toughest part of it is breaking it into perfect cubes like that. This one only has 2 terms, but it's a second degree. And so the first thing I would do is factor out a 6. So let's factor that 6 out front. And then whatever we write there, we put it underneath. So that's x squared minus 9. Ooh, so we're not done because that's a perfect square minus a perfect square. The difference of 2 perfect squares always work out to be conjugates. Remember when we were multiplying, I said those are conjugates because just that one sign was opposite. That's a plus and a minus, a 3 and a 3. And see what's going to happen. 3x, negative 3x, 0x. That's why there aren't 3 terms in it. That's why it's a second degree binomial instead of a second degree trinomial. So we like difference of squares and we like perfect cubes. The sum of perfect cubes or the difference of perfect cubes. Both are factorable. And that's it for page 2. I'll do page 3 next.